In this video, I will teach you how to sketch the graph of a function by finding its critical points and point of inflection if there are any. The critical points of a function are the maximum and the minimum points on its graph, while the point of inflection is the point where the graph changes its concavity. Not all functions have critical points or point of inflection. Sometimes a function just have a maximum point or a minimum point. But if a function has both maximum and minimum points, it definitely has a point of inflection also. A function can also have a maximum point and a point of inflection at the same time, or a minimum point and the point of inflection. Look at the graph on the left. This is the graph of the function y equals f of x, and it contains points a, b, c, d, and e. And each of these points has their corresponding coordinates. Right. Now we say that a function is increasing as x increases if its first derivative is a positive number, or that is greater than 0. On the other hand, f is decreasing as x increases if its first derivative is less than 0, or that is, it's a negative number. Now we recall that the first derivative of a function is interpreted as the slope of the tangent line to the graph of f. So therefore, if f prime of x is greater than 0 or positive, it means to say that the line or the tangent line is inclined to the right. And if the first derivative of f of x is less than 0, or that is, it's a negative number, it means to say that the tangent line is inclined to the left because its slope is a negative number. Now going back to the graph, A and E, points A and E, are maximum points of the graph of the function y equals f of x. Now point A is also called a maximum point because at some interval in the graph, A is the highest point. And point E obviously is the highest point all throughout the graph, but at a certain interval, E is also the highest point in the graph of the function. Now point C here is a minimum point in the graph. Notice that at the maximum points, on the left side of the maximum points, the function is increasing, and on the right side of the maximum points, the function is decreasing. Now on the other hand, on the left side of the minimum point, the function is decreasing, and on the right side of the minimum point, the function is increasing. Just let me draw some tangent lines on the left side of point A. This is one tangent line on the left side of point A, and obviously it is inclined to the right, so its slope is positive. Because on the left side of point A, the function is increasing. Let me draw another tangent line on the left side of point A. Now the green line is another tangent line on the left side of point A, which is a maximum point. Again, it is inclined to the right, therefore it has a positive slope. So on the left side of point A, all the tangent lines have positive slopes because f is increasing on the left side of a maximum point. Now look at the tangent lines on the left side of point C, which is a minimum point. Both of them are inclined to the left, therefore they have negative slopes. So because the function is decreasing on the left side of a minimum point. Now points B and D are points of inflection. Point B is a point of inflection because that is where the graph changes its concavity. So from concave downwards, in this portion of the graph, concave downwards, Now it is concaved upwards over here on the right side of B. So point B is a point of inflection. The same goes for point D. On the left side of point D, the graph is concaved upwards. On the right side of point D, the graph is concave downwards. Now, if f prime of x is greater than 0, when the function is increasing, and it is less than 0 when the function is decreasing, where is f prime of x equal to 0? F prime of x is equal to 0 at these points. You see, whenever f prime of x is equal to 0, it means to say that the slope of the tangent line at a certain value of x is equal to 0. So when f prime of x is equal to 0, it means that the slope of the tangent line at that particular portion of the graph is 0. So when is the slope of a line equal to 0? Whenever the line is horizontal. So the tangent lines at the critical points and at the point of inflection of the graph are all horizontal lines. So at point A, the tangent line is a horizontal line. At point C, where it is a minimum point, the tangent line is a horizontal line. At point E, the tangent line is also a horizontal line. And at points B and D, the tangent lines are horizontal lines as well. Now, since A is a maximum point of the graph, we say that y sub A is a maximum at x sub A. Or we can say that y sub A is a maxima at x sub A because we are just pertaining to a single number. Now, y sub E is also a maxima at x sub E this time because point E is also a maximum point. Now, because point C is a minimum point, we say that y sub C is a minima at x sub C. Now we call x sub A, x sub E, and x sub C critical values of the function. Critical values of the function. Now, not all critical values pertain to x-coordinates of critical points. There are some tests to know whether a critical value is an x-coordinate of a critical point. And that is what you're going to learn next. Oh, by the way, maxima and minima are collectively called extrema. Extrema of the function are the maxima and minima of the function. Now, how do we find the critical values of a function? Since the critical values might be the x-coordinates of the maximum and minimum points of the graph of the function, and at the maximum and minimum points of the graph, f prime of x is equal to 0. So to find the critical values, we simply find the first derivative of the function and then equate the first derivative to 0. And then from there, we can obtain an equation and you can solve for x from that equation. For example, we want to find the critical points of the graph of y equals x cubed plus 3x squared minus 1. No, let me change the constant to 2. So the function is y equals x cubed plus 3x squared minus 2. So the first thing that we are going to do is find the first derivative of the function. Okay, so y prime, in this case, is equal to 3x squared plus 6x. The next step is to equate y prime to 0. So equating y prime to 0, so we'll have 0 equals 3x squared plus 6x. And then we have obtained an equation in terms of x. The next step is to solve for x in the equation that we have found. So 0, by factoring, we can factor out 3x from both terms, and we'll get 3x times the quantity x plus 2. And then equating both factors to 0, we equate 3x to 0 and x plus 2 to 0 also. We'll get two values for x. One is 0 and the other one is x equals negative 2. Now these are the critical values of the function. Now it doesn't necessarily follow that one of these will lead to a maximum value of y and the other one will lead to a minimum value of y. We have to test whether these critical values pertain to the x-coordinates of a maximum and a minimum point on the graph of the function. So step 4 is when we test the critical values if they yield to a maximum or a minimum value of y. Now there are two tests that we can use. The first one is the first derivative test. The second one is by the second derivative test. Now, the second derivative test is the easier one, but it doesn't always work. So it doesn't work for some functions. Later on, you'll learn about it. So let's test the critical values by the first derivative. Now, recall in the first slide that f is increasing at the left side of a maximum point. So that is, f prime of x is greater than 0 on the left side of a maximum point, and f prime of x is less than 0 on the right side of it. So in the first derivative test, we just have to test or check the change in the sign of f prime of x as x passes through the critical value. So by the first derivative test, we'll test x equals 0 first, and then later on we'll test x equals negative 2 also. So we'll have to check the sign of f prime as x passes through 0. So I will just create a table. Okay, at x equals 0, f prime obviously is equal to 0. And then I'll choose values on the right and on the left side of 0. It's important that you choose some values very, very close to 0. Let's say on the right side 0.1, on the left side negative 0.1. Now, you just have to look at the sign of f prime of x whenever x is equal to negative 0.1 and positive 0.1. Remember that this is our f prime or y prime. Let me change this to y prime so you'll not be confused. So this is the sign of y prime. Just sign of y prime. We don't need the exact value anymore. What is the sign of y prime? This is y prime. What is the sign of y prime whenever x is equal to negative 0.1? So let's try to substitute negative 0.1 for x. That's 3 times negative 0.1 quantity squared plus 6 times negative 0.1. Remember, we just need the sign of y prime. So y prime is either greater than 0 or less than 0. Now, obviously, because 6 is greater than 3, and the second term here would be a negative number because 6 is multiplied by negative 0.1. Then this value is less than 0, or a negative number, less than 0. So y prime when x is equal to negative 0.1 is negative. Now what about y prime, the sign of y prime whenever x is equal to 0.1? So 0.1 squared plus 6 times 0.1. Now this is very obvious that y prime is greater than 0 whenever x is equal to 0.1. So this is plus. Now if 0 is a critical value and on the left side of 0, the slopes of the tangent lines are all negative. And on the right side of 0, the slopes of all the tangent lines are positive. Then what do we conclude? from the explanation a while ago, we can conclude that 0 is the x-coordinate of a minimum point of the graph of the function. So therefore, if y prime changes sign from negative to positive as it passes through a critical value, then we say that y is a minimum at that particular value of x. Let me write that down. Again, if y prime changes sign from negative to positive through a critical value, then y is a minimum at that particular value of x. Therefore, y is a minimum at x equals 0. So 0 is an x-coordinate, the x-coordinate of a minimum point of the graph of the function. So we are looking for the critical point, so we need the y-coordinate of 0. So when x is 0, what is the value of y? Remember that y is equal to x cubed, so that's 0 cubed plus 3x squared, so that's 3 times 0 squared minus 2. So the value of y is equal to negative 2. So this is from the original given function. So therefore, the point with coordinates 0, negative 2 is a minimum point. Minimum point. So that's how the first derivative test goes. Now we test the other value. Test x equals negative 2. Negative 2. So we want to know this time if negative 2 yields to a maxima or a minima. Okay, using the first derivative test again. So we'll just create a table. And then we have to look for the sign of y prime as x passes through negative 2. So we have to choose values on the right side and on the left side of negative 2. But remember, we have to take some values very close to negative 2. So let's say on the right side, negative 1.9. On the left side, negative 2.1. Okay, whenever x is equal to negative 2, the value of y prime is 0. And then what is the sign of y prime when x is equal to negative 2.1? Let's take a look at that. So what is y prime whenever x is negative 2.1? So going back to y prime again in step 1, that's 3 times negative 2.1 squared plus 6 times negative 2.1. So it's either y prime is positive or negative here. Alright, now 3 times negative 2.1 squared would be greater than the second term, so this would be positive. Greater than 0, so this is positive. And then what is the sign of y prime whenever x is negative 1.9, negative 1.9 squared plus 6 times negative 1.9. Now this time the value of y prime is negative, so less than 0, so this is negative. Okay, remember that on a maximum point, on the left side of the maximum point, the tangent lines are all inclined to the right, therefore their slopes are all positive. And on the right side of a maximum point, all the tangent lines are inclined to the left, so therefore their slopes are all negative. Okay, so in this case, for the first derivative test, if y changes sign from positive to negative through a critical value, then y is a maximum at that particular value of x. So therefore, y is a maximum at x equals negative 2. Now we don't just want the maximum value of y at x equals negative 2. We want to have the maximum point because we are looking for the critical points here. So we want to have the y coordinate of the maximum point whenever the x coordinate is negative 2. So what is the value of y whenever x is equal to -2? Let's look at the original function again. So y is equal to x cubed, so that's -2 cubed plus 3 times -2 squared minus 2. What is the value of y here? So we have here -8 plus 12 minus 2. Alright, so y is equal to +2. Okay, so we have now the maximum point. The x-coordinate of the maximum point is -2. The y-coordinate is 2. So it is a maximum point. Alright, there you have it. The critical points of the graph of the function. So that's how you do the first derivative test. So you just have to look at the change in the sign of y prime through a critical value. So if y prime changes its sign from negative to positive, then you conclude that y is a minimum at that particular value of x. And if y prime changes its sign from positive to negative, then you conclude that y is a maximum at that particular value of x. Now, if y prime does not change sign through a critical value, then a critical value will not yield to either a maxima or a minima. That's all for this video. We'll continue in the next one.